All right, Friday, March 27th, 2020. Today is the review day because I'm going to assign a test and you guys will have the weekend to do it. So it'll be due on Monday, March 30th, 2020. Once again, this is one of the most important concepts that will get you into calculus as well, but algebra 2. So I would call this the blurry area between algebra 1 and algebra 2. See if you guys can do the first 4 problems independently. Okay, so let's start with problem number 1. n minus 7 times n minus 3 equals 0. Once again, the main idea is the zero product principle. The zero product principle states if I have a multiplication problem where the answer is 0, then we must account for both factors that make the product 0. So let's start with the left factor. Well, n minus 7 can be 0, or n minus 3 can be 0. Okay, so now I'm going to set n minus 7 equal to 0. How do I get n isolated? I'm going to add 7 to both sides. That cancels out, that cancels out. So n equals 7 is one of the solutions. Do I move on to problem number 2? No. It says find the solution set, not solve for the indicated variable. There are multiple solutions in the solution set. So we've got n minus 3 equals 0 as well. How do I get n isolated? Right, I'm going to add 3 to both sides. So then n equals positive 3. There are 2 solutions in the solution set. So then I'm going to check my work. Let's say I plug in the first solution, n equals 7. So if I plug in n equals 7, I get 7 minus 7, which is 0. I get 7 minus 3, which is 4. 0 times 4 is 0. So that checks out. I didn't have space. I just wanted to make sure that we do like 2 of these check our work kind of problems. All right, but what if I plug in n equals 3? Well, 3 minus 7 is negative 4. Well, that's adorable. 3 minus 3 is 0. Negative 4 times 0 is in fact 0. There, we have checked our work. There are 2 ways to get that statement equal to 0. Okay, moving on. So a plus 10, a plus 4 equals 0. The zero product principle states that we must account for both factors that make the statement true. So a big or in the middle. So we've got a plus 4 equals 0, or a plus 10 equals 0. So now let's solve for a. Let's say I take the left side, a plus 10 equals 0. How do I undo that layer? I'm going to minus 10 on both sides. And I'm going to get a equals negative 10. Okay, the other side, a plus 4 equals 0. So I'm going to get a isolated by subtracting 4 from both sides. So then a is equal to negative 4. I didn't have no space to check my work. I'm going to do that for problem number 3 as well, but if you want to check your work, if I plug in negative 10 for a, I'm going to get negative 10 plus 10, negative 10 plus 4. That's going to be 0 times negative 6. Don't care. 0 times negative 6 is still 0. Plug in a equals negative 4. I'm going to get negative 4 plus 10, negative 4 plus 4. That's going to be positive 6 times 0 equals 0. And that's also true. Moving on to problem number 3. T minus 19, t plus 30 equals 0. I'm going to split it up into 2 equations using the zero product principle. And that's going to come back for the rest of the school year. So t plus 30 equals 0, or t minus 19 equals 0. So now, how do I solve for t? Okay, so I'm going to minus 30 on both sides of the right equation. So I'm going to get t equals negative 30 is one of the solutions. And then t minus 19 equals 0. I'm going to add 19 to both sides of the equation to get t isolated. So therefore, the two solutions are that t equals positive 19 or t equals negative 30. Those are the two solutions I'm looking for. Okay. Number 4, d minus 75 times d plus 62 equals 0. I'm going to split them into both equations. And I'm going to get d plus 62 equals 0, or d minus 75 equals 0. So then I'm going to split them up into two equations, solve for d. Right? So then I'm going to add 75 to both sides. So that d equals positive 75. Or I'm going to subtract 62 from both sides of the right equation. And I'm still going to get d equals negative 62. Sorry, I'm holding the iPad in my left hand, so I'm a little off balance right now. But yeah, those are the quote-unquote novice level problems on the exam. Okay, moving on. Turn the page. This is where it gets to bridge the gap into Algebra 2. Well, my first instinct for m squared plus 6m equals 0. Oh, sorry. I want to make sure. Do these two problems independently. Okay. My first instinct for problem number 5, m squared plus 6m equals 0, is I want to get m isolated, but that's going to be tricky because then I'll get m squared equals negative 6m. But luckily, I know how to factor out the GCF. Can I take something out of m squared and positive 6m? I'm going to factor out an m. And now, m times what is m squared? M. M times what is 6m? Positive 6. So now I've got m times the quantity of m plus 6 equals 0. Now I can use the zero product principle. In fact, I like this version of the zero product principle because one of the solutions is very, very easy because I don't want to work. I'm on your guys' side. I don't want to work. M is already isolated on this left side, so m equals 0. That's the... Oh, I love it when I don't have to work. Or m plus 6 equals 0. I got to work a little bit over here, but that's not too bad. So then I'm going to do what I normally do. I'm going to isolate the variable. I'm going to subtract 6 from both sides. Therefore, my two solutions are that m equals 0 or m equals negative 6. Now I'm going to check my work on the right side. Well, I'm going to start with the easy part. So I'm going to plug in m equals 0. 0 squared plus 6 times 0. 0 squared is 0. Plus 6 times 0, that's 0. 0 plus 0 is 0. Is that the only solution? No. So I'm going to plug in at m equals negative 6 for the variable. So that means m equals negative 6 results in negative 6 quantity squared. Oh, that's broken. Let me get my multicolored pen. There we go, black. Negative 6 quantity squared is positive 36. Positive 6 times negative 6 is negative 36. 36 minus 36 is, in fact, 0. We've got two ways to get the product equal to 0. P squared minus 15p equals 0. What can I factor out of p squared and negative 15p? Okay, so I'm going to factor out a p. Now, p times what is p squared? Another p. P times what is negative 15p? Minus 15. Okay, so then I have p times the quantity of p minus 15 equals 0. Now I'm going to use the zero product principle. Oh, I love it when I don't have to work. It's my favorite part. So the left side says p equals 0. Big advantage. But the other part says p minus 15 equals 0. So now p minus 15 equals 0. I'm going to add 15 to both sides, getting me p equals positive 15. The two solutions of this problem are p equals 0 or p equals positive 15. Check my work. So now I'm going to plug in p equals 0 and p equals 15. And now, let's do the p equals 0 part. 0 squared is 0. Negative 15 times 0, let's just put minus 0 or plus 0, it doesn't really matter. 0 minus 0, 0 plus 0, it's still going to be 0, so that checks out. Then, 15 times 15. Come on, phone.
It's 225.
I love my phone. 15 squared is 225. Well, then negative 15 times positive 15 is negative 225. 225 minus 225 is in fact 0. And I forgot to check my work for a problem like problem number 7, so I'm going to do that on the right side when we're done. Okay. So 8x plus 5 times the quantity of 3x minus 17 equals 0. Warning, you may get a fraction, but it's not the end of the world. So it's not as nice as problem number 5 and 6 where I don't have to work. I gotta work. I gotta do a little bit of algebra. It's not the end of the world. 8x plus 5 times the quantity of 3x minus 17 equals 0. I'm going to do the zero product principle, which states, let's set 8x plus 5 equal to 0. And let's also set 3x minus 17 equal to 0. Okay? Little divider right there. So now, let's subtract 5 from both sides. 8x plus 5 equals 0. I'm going to subtract 5. And that gets me 8x equals negative 5. And then 8x equals negative 5. I'm going to divide both sides by 8. So I get x equals negative 5/8. If you want to convert that to a decimal, because I know it ends in the decimal actually ends, be my guest. I just see a fraction and I just go good enough. The other way is 3x minus 17 equals 0. So 3x minus 17 equals 0. I'm going to add 17 on both sides. So I get 3x equals positive 17. Now I need to get that x isolated. I'm going to divide both sides of the equation by 3. And I know it's an improper fraction, but x equals 17/3, good enough. In fact, when I check my work, I actually kind of like it as an improper fraction. Let me show you what I mean. So let me just get these fractions out of the way. Let me plug them into our work. 17/3. 17/3 and negative 5/8. Okay. All right. So if I plug in x equals negative 5/8, well, that 8 over 8 cancels out, leaving me with negative 5 plus 5. I don't really care what this is. I'm just going to put negative 15/8 minus 17. It's complicated. I don't feel like it. So negative 5 plus 5, 0. And I'm just going to leave it as it is. Negative 15/8. minus 17. I could get common denominators. But you know what? I have a bachelor's degree in math, and even I don't want to work with fractions sometimes. But that's why I like the zero product principle, because 0 times, I really don't care what this right factor is still 0. Let's take a look over here. Once again, 8 times 17. 8 times 17. 136 thirds plus 5. Once again, I'm just going to rewrite it. 136 thirds plus 5. Well, 3 times 17 over 3, I know that 3's are going to cancel out, leaving me with just 17 minus 17. I mean, come on. Do I even care at this point? 136 thirds plus 5 times 0. It still checks out and becomes 0. Zero product principle is genius. All right. Whew. I'm going to give myself a little bit of a breather. See if you guys can do 5n squared minus 40n equals 0. Okay. So then I'm going to do 5n squared minus 40n. This is where it gets a little bit more challenging, because now I'm looking for the greatest common factor of 5n squared and 40n. What number can I divide out of 5 and 40 and still get a whole number? Well, just 1 and 5, but 5 is the greatest common factor, and so 5 is going to be one of the factors. N squared and n also share an n, so I'm going to factor out the GCF 5n. Now, 5n times what is 5n squared? N. 5n times what is negative 40n? Negative 8. So now I've got 5n times the quantity of n minus 8 equals 0. I can use the zero product principle right now. So I've got 5n equals 0, or n minus 8 equals 0. I like this left part of the equation. 5 times what is 0? I love it when I don't have to work, because I'm a lazy mathematician sometimes. But no. 5n equals 0. 5 times what equals 0? Love it. N equals 0. Or n minus 8 equals 0. Ooh. Big or. N minus 8 equals 0. So I'm going to add 8 to both sides. And I'm going to get n equals positive 8. Okay. We're going to do up to number 13. See if you guys can do these 3 problems independently. Okay. 8x squared plus 72x equals 0. What is the greatest common factor I can take out of 8x squared and 72x? Okay. Well, the greatest common factor of 8 and 72, I could take out a 1, not really helpful. I could take out a 2, a 3. No, actually I cannot take out a 3 because 8 divided by 3 is a decimal. But anyway, I can go on and on and on. But the point is, I can factor out an 8x. I'm going to take advantage of that fact. So then I've got 8x times what is 8x squared? 1x. 8x times what is 72x? Positive 9. All right, so now I'm going to do the zero product principle. Huge weapon, huge tool. So then I get 8x equals 0, or x plus 9 equals 0. Oh, I love it when I don't have to work. 8x equals 0. So 8 times what is 0? And then x plus 9 equals 0. Subtract 9 from both sides. And x equals negative 9. So the two results that I'm looking for, I'm going to make that negative a little darker. So my two results are going to be x equals 0 or x equals negative 9. I want both. Now, number 10. 12x squared plus 16x equals 0. Well, contrary to the previous problems, I can't divide 12 from 12x squared and 12 from 16x and get whole numbers. What is the greatest common factor of 12x squared and 16x? I'm going to factor out not just a 1, not just a 2, but a 4. So I'm going to factor out 4x from both terms. Now, 4x times what is 12x squared? 3x. 4x times what is 16x? Positive 4. Now, I'm going to use the zero product principle, and on the left, I don't want to work, and it's awesome. So, I've got 4x equals 0, or 3x plus 4 equals 0. I love it when I don't have to work. X equals 0 is on the left. The other part is, I gotta work with a fraction. It's not the end of the world though. So 3x plus 4 equals 0. I'm gonna undo the outer layer. I'm gonna subtract 4 from both sides. So then I've got 3x equals negative 4. I'm gonna isolate that variable by dividing both sides by 3. Sorry about the space. So the other solution is, can I reduce 4 over 3? Nah, but a negative divided by a positive is still a negative, so the answer is negative 4/3. Just making it clear that we've got two solutions, so I put one in red. Okay. All right, number 11, plenty of space. Okay. 30x squared minus 18x equals 0. This one, what is the greatest common factor of 30x squared and 18x? Well, so that's going to be 6x, because 6 can go into 30 and 6 can go into 18. 6x times what is 30x squared? It's going to be 5x. 6x times what is negative 18x? Negative 3. So 6x times the quantity of 5x minus 3 is equal to 0. Now I'm going to split them into two cases, and on the left, I don't have to work. So then 6x equals 0, or 5x minus 3 equals 0. So 6x equals 0. 6 times what is 0? X equals 0. Plug it into the other side of the equation now. We've got 5x minus 3 equals 0. I'm going to add 3 on both sides to undo that layer of x, leaving me with 5x equals positive 3. And now I need to get x isolated. I'm going to divide both sides by 5. Luckily, it's still a positive. Let me make that a little bit more knocked out. 3 over 5 is a fraction, so my other solution is positive 3/5. Okay. Two more problems. I wrote down a 12. I'm going to write down a 13 because I forgot about this particular case. So I'm going to write down problem number 12. See if you can do this problem independently while I write problem number 13. Okay. I'm going to write down problem number 13 down here. Forgot about the square. Let's say I make this up and I go with 13x minus 7, quantity squared equals 0. See if you can do that problem independently as well. Okay. All right, so 12, I'm just going to approach this like an anxious high school student. Well, the GCF of 96x squared and 52x is 4, but what if you're nervous like me and you go, do I need the GCF? You do if you want to if you don't want to simplify fractions even further. However, I'm not ruling out the possibility of just making it easier and dividing it by 2x. Okay, so I'm just going to show you right here that if I divide by 2x times 48x plus 52 divided by 2 is 26. You notice in this that I'm going to have to reduce this fraction because it's going to be some sort of fraction involving 26 and 48, which can be divisible by 2 yet again. So just to ease everybody's anxiety, I will allow you guys to factor out the not so much the GCF, but if you do factor something smaller than the GCF, I expect you guys to be able to reduce this fraction. So just to give everybody some peace of mind, 2x equals 0. X equals 0 is one of the solutions. Whew, I don't have to work. The other part, let's say I do it like this. 48x plus 26 equals 0. Let's say I subtract 26 from both sides. And again, if you did it by factoring out 4, you're in the clear, don't worry. But I'm going to show you another way to do it. 48x equals negative 26. So now I've got 48x equals negative 26. Divide both sides by 48. Now, I look at this and go, x equals negative 26 over 48. Can I reduce this fraction? Yeah, I'm going to divide the top and bottom by 2 and get x equals, still a negative fraction, 13/24. So the beauty of, let's just say I do this problem over here. If I factor out the 4x ahead of time, so that means 4x times what is 96x squared? That'd be 24x. 4x times what is 52x? Positive 13. Do you see why the GCF is super helpful? It's going to do the reducing for you. Okay? Just wanted to ease everybody's anxiety. Now, for the last problem, just to make sure that we're clear, what happens if you have a binomial getting squared and it equals 0? Well, remember that a binomial getting squared is the same thing as rewriting the problem 13x minus 7 times 13x minus 7 equals 0. But if I use the zero product principle, how many solutions am I going to get? If I split them apart, I get the exact same expression. 13x minus 7, 13x minus 7, and I said both equations equal to 0. I don't want to waste my time. You remember when we did the zero product principle on the first day? This is an example of case 3. They would both be equal to 0 at the same time. So I'm not going to waste my time. I'm just going to pick one of them and just solve for x. So 13x minus 7 equals 0. I'm going to add 7 to both sides. And then 13x equals 7. I'm going to divide both sides by 13. And my solution is x equals 7/13. If you have any questions, please feel free to email me. I'm happy to help with the zero product principle. I don't want to see any holes when you guys get into Algebra 2. Okay? I'll email you guys with the directions on what to do with the take-home test. If you prefer a Google Share file so that you guys can make your own copy of the view-only file, that's definitely an option. If you prefer a PDF so that you can print it at home, I can do that as well. Okay? Have a good day.